All right, so section 10.2 is an introduction to logarithms. So I know it's a strange word, but it says, suppose you want to know how many times you have to multiply 2 by itself to get 8,192. Oh, thank you. So the way that you guys probably would do it at this point is you would just keep doing 2 times 2 times 2 times 2 times 2, or 2 to the 7, 2 to the 8, 2 to the 9 on your calculator, right? So we don't really know how to find that otherwise. Chris, put your computer away, please. So a logarithm is actually an exponent, so it's going to have a lot of the similar rules as exponents. So it's the exponent to which a specific base is raised to be given a value. So we're going to be able to solve equations that look like 2 to the x equals 8192. Okay, without doing like raised to the raised to the raised to. And even things like 2 to the x equals 5. You guys can probably all give an estimate for that. 2 to what power is going to be 5? It's not a nice whole number, is it? Yeah, it's somewhere between, what two numbers? 2 and 3, right? So maybe 2.5 could be a good guess for that. Well, we're going to find out how to actually solve that with logarithms, okay, to get that precise value. All right, so this is the most important thing that you're going to learn in this chapter. If you can do this, you'll be able to solve almost all the problems on the test. Are we ready for it? So we're going to switch something from exponential form, so like b to the x equals y, into what we call logarithmic form. So logarithmic form uses these same numbers, and it's the same equation, kind of. It's just written in another way. So we write it as log base b. So this is a subscript. You guys know what a subscript is? Not an exponent, but it's a little tiny number that's down a little bit, of y equals x. So the log and the y are on the same level. The b is a little subscript. Okay, that y is not hanging up in the air as an exponent. A lot of people mess that up. Okay, so log and y are on the same level. The base is a subscript. All right, so we're going to switch things all the time from logarithmic form to exponential form. And the way I typically have students do it is if it's in logarithmic form, they kind of identify the base of that logarithm, the subscript, and they raise it to the other side of the equation. So they're going to raise it to the x, and it's going to equal what's left over here, the y. Okay, that's how we're going to switch it. Do you guys see that? B to the x equals y. That's how we switch it back to this form. Okay, it's going to be a little bit harder when we go from exponential form, but we got this. All right, so if I have log base a of x equals y, can we all switch it? A to the y, whoops, I don't know why I'm writing g. So a to the y is equal to x. Do you guys see it? All right, now we have 2 to the 3 equals x, and we want to go back to logarithmic form. Michael, so how would we do this? So we'd have log. So think about it. Okay, the base of the exponent, this one, this is the base of the exponent, is also the base of the logarithm. So we're going to have log base 2 of x equals 3. Do you guys see the pattern? So we have 2 raised to the 3 equals x. Okay, so we should all be able to switch these around. So this next one, I have log base a of a to the x equals y. So a to the y equals, what's left? The a to the x. What do you think we'd be able to say when we have a to a number equals a to another number? Yeah, like x and y are equal to each other. And then this last one, 4 to the negative 2 equals x. Everybody try it. See if you can get it. If you can't get this, if you can't switch them around, you're not going to do well on the test, I promise. This is like the most important thing. So we have log base 4 of x equals negative 2. Do you guys see it? So 4 raised to the negative 2 is what gives us the x. Okay, so we think we can handle that, switching things around? All right, so number 5 says, well, let's solve for variables. So, 2 minutes ago, you guys had no idea how to solve a logarithmic equation. You've seen that log button on your calculator, but you don't really know what that log button means. Now we can solve this. So we have log base 10 of x equals 3. So all we do is we switch the forms. So we're going to switch it, and it's going to be 10 to the 3 equals x. Do you guys see? Do we know what 10 to the 3 is? Yeah, it's 1,000. 10 times 10 times 10, right? So it's a 1 with 3 zeros equals x, 1,000. You solved a logarithmic equation. Easy, right? So the next one, 16 to the 1/2 is equal to x. If you remember, 16 to the 1/2 is the square root of 16. So x is 4. Perfect. You actually can't take the log of a negative, so you wouldn't be able to say plus or minus 4. So, and we'll talk about that in a second. All right, so the next one, log base 5 of 3x minus 2 equals 2. So switch forms. So we should have 5 to the 2 equals 3x minus 2. Chris? Yeah?
Does it matter which order you put it in? So could you put it 3x minus 2 equals 5?
Yep. So 5 to the 2 is equal to 25. We add the 2 over and we get 27 equals 3x. So we get x equals 9. Done. Is this making sense? I don't know. The last one's kind of weird, isn't it? So how do you switch forms on this one? Yeah, you got to add that 3 over. You have to get that log part, the part that has like the base, like log base something of something else all together. Like that needs to be all by itself on one side. So we're going to add the 3 over. So we get log base 2 of 2x plus 1 equals 9. And then we switch it. So 2 to the 9 equals 2x plus 1. Okay, just found 2 to the 9 for us. 512, is that what it says? 512 equals 2x plus 1. So subtract the 1 over, so we get 511 equals 2x. So x equals 511 divided by 2. You just want to see the decimal, don't you? What's the decimal? 255.5 would be fine. All right. But if it's not a calculator section, leave it like that, right? Not a big deal. All right, so a common logarithm. So this is the button that's on your calculator that says log. Okay, so the calculator can't have all the different logs on it. It can't say log base 1, log base 2, log base 3, log base 4, log base 5. So there has to be some kind of common one. Okay, the common logarithm is going to be base 10. So if no base is written for a logarithm, we assume it's base 10. So if you see log of 5, this means that it's really log base 10 of 5. Okay, so there's an invisible base there. So base 10. Okay, so let's try these. So it says log of 1. Okay, so let's rewrite. So we're thinking log base 10 of 1. Okay, these will be on the non-calculator section, so you need to know how to do these without a calculator. Okay, so here's what we're going to think. So we're going to say that that's all equal to x. So you can write equals x on your page if you need to. And now think about switching forms. Okay, identify the base of the logarithm is 10. And now we switch it to that exponential form. So can we all do that? 10 to the what? 10 to the x equals 1. So let's write that. So when we're in our head, we're saying, okay, 10 to what power gives me 1? Do you guys know 10 to what power gives you 1? 0. That's it. So your answer is 0. So when you see log of 1 is 0. So how about this one? So this is log base 10 of 10,000 is equal to x. So what we're thinking in our head is we're saying 10 to some power gives me 10,000. Do you guys know the tricks for tens? Yeah, it's how many zeros, right? Like if I had 10 squared, that's 10 times 10, so it's 100. 10 cubed is 10 times 10 times 10, which is 1,000. It gives you the number of zeros you want. So if you see 10 to the x equals 10,000, what power do we raise it to? 4, right? Because we just count these zeros. We have 1, 2, 3, 4. Done. All right, so what should the next one be? Can I do this without writing anything? Yeah, what should it be? 3. We got this down. That's why log of 1 was just 0. There were no zeros after it, right? Chris, you're not paying attention at all. Pay attention. So if I have log base 5 of 125, so we're going to do the same thing. So some of you guys are going to be able to do this without writing the x eventually. That's the goal. Okay, but for now, if you guys don't understand, just write equals x. And we say 5 to some power equals 125. Okay, do we know that power? Yeah, it's 3. Do you guys know that? 5 to the 1 is 5. 5 squared is 25. If I multiply by one more 5, I get 125. So x is equal to 3. So how about this next one? Are you guys getting good at this? So 15 raised to some number is giving you 1. 15 raised to some number equals 1. So it has to be 0 again, right? So log base anything of 1 is always equal to 0.
Why do I have to equal 0?
Because you're saying 15 raised to some power gives you 1. So if you had 15 to the 0, that's how you're getting 1. Right?
So you're solving for the variables.
You're finding the power. That's why a logarithm is an exponent. You're finding the exponent that makes this true. So you have 4 to some power equals 1/4, right? If we set this all equal to x and we're switching. So we have 4 to the x equals 1/4. Okay, this is a little tricky. Are you guys pretty good at this? It is -1. Good, Eric. Do you guys see it? -1? Because we know that if I raise 4 to the -1, it means 1 over, right? 1 over 4. So if you're confused, you could rewrite this 1/4 as 4 to the -1. And you can say, oh, 4 to the x equals 4 to the -1. That's why x is equal to -1. Okay. Good so far? All right, so the next one. So special properties of logarithms. So if you see something, we just talked about this, that looks like log base b of, well, we didn't talk about this one. Log base b of b equals 1. Log base b of b equals 1 is really b to the 1 equals b in its exponential form, right? Do you guys see that? B to the 1 is equal to b. Okay, so log base b of b is always equal to 1. So if you see log base 7 of 7, it's equal to 1. Or if you see log base pi of pi, it's equal to 1. All right, does that make sense? Because pi to the 1 is what gives us pi, right? Okay, and then the other one is if we see something b to the 0 equals 1, we know b to the 0 is equal to 1. So if you see it in its logarithmic form, log base b of 1, that's always equal to 0. So you could see log base 247 of 1 equals, and you could say, oh, it's log base 247 of 1. That means 247 raised to the 0 gives me 1.
Why are you raising it to 0? That's just how you put it.
Right? That's what that's all equal to. It's all equal to 0. Like 247 raised to what power gives you 1? So if you raise it to the 0, it makes 1. So if you see log base 5 of 1, you should know immediately that it's 0.
So if the exponent is 1, or
It's not an exponent.
if it's like 1 other than the log that equals 0.
Uh-huh. Okay, so let's go the other way. So let's look at two things and let's talk about why it doesn't work. Okay, so this one. So if I have log base 0 of 3. Okay, so think about setting that equal to x and writing it in exponential form and think about why that can't possibly work. So Anna Catherine's got it. Why? Yeah, 0 to the x can't possibly be 3, right? So that can't work. And then the same idea here. What if I have log base 1 of 3 is equal to x? Well, when we switch it, it's saying 1 to the x equals 3. 1 to some power equaling 3, that's not possible, right? It's going to be 1, right? So this can't work as well. Okay, so we can't have a base as 0 or 1. And I think I said that when I defined the logarithm originally. Well, actually, I said it here. So b is not equal to 1, and b is bigger than 0. Okay, it also can't be negative. So we can't have, like, log base -2 of 3 equals x, because we can't say -2 to some power equals 3. Okay, so we're not going to do that. All right, so we can't have negatives as well. All right, so let's see what the graph looks like. So it says use the given values to graph each function, then graph its inverse. Okay, so logarithms are inverses of the ones we learned yesterday, of the exponential functions. Do you guys remember inverses? Yeah, so inverses are that reflection of the line y equals x, so it's all interconnected. Okay, so if I'm graphing this out, if I have 3 to the negative 2, that means I have 1 over 3 squared, which is 1/9. If I have 3 to the negative 1, that's 1 over 3 to the 1, which is 1/3. 3 to the 0 is going to be 1. 3 to the 1 is 3. And 3 to the 2 is 9. Okay, so this is kind of what we learned yesterday, exponential functions. So we're going to have negative 2 comma 1/9, so it's going to be really close to the axis. Negative 1 1/3. 0 1. 1 3. 2 9. I think it's up there. It's kind of hard to see. So it's going to come down, and it's going to go along that x-axis because there's a horizontal asymptote there. So there's a horizontal asymptote at y equals 0. But there's no vertical asymptote. It's going to continue to get bigger on the right side. Okay. So it's not going to go along any line. Okay, so when we graph inverses, we switch all of the x's and y's. So that means that what we had previously, we're going to have instead 1/9 comma negative 2, 1/3 comma negative 1, 1 comma 0, 3 comma 1, and 9 comma 2. So we're going to have 1/9 negative 2, 1/3 negative 1, 1 0, 3 1, 9 2. Okay. So when we had a horizontal asymptote before, did you guys see that we have a vertical asymptote now? And this ends up being a reflection over the line y equals x. So the first one that we graphed was, not log, sorry, it was y equals 3 to the x. Now this one, we switched our x's and y's. So if we switch our x's and y's, if we had y equals 3 to the x and we switched them, we'd have x equals 3 to the y. Okay, so let's think about this. So if I have x equals 3 to the y and I want to get y by itself, I want to solve for y, I need to be able to drop that exponent. Whenever we're trying to drop an exponent, that's when you're using logarithms. So Caitlin, do you get this? So what would I switch this to if I was switching forms? Uh-huh. Uh-huh. Yep, do you guys see it? Do you guys see how they go the same? 3 to the y is what gives me x. So that's the new form. That is what we just graphed over here. So this other one is y equals log base 3 of x. That's the inverse. Okay, because we switched our x's and y's and we solved for that new y. So a logarithmic function is the inverse of those exponential functions. So a function of the form f of x is equal to log base b of x, and it ends up being the inverse of f of x equals b to the x. So that's kind of confusing for students because they're like, wait, it's supposed to be like b to the x equals y. You know, like you're supposed to switch them around, but remember we switch our x's and y values, so we've done like the switching. Okay, and then it says, note, the domain and range of these functions are switched. So we knew that the range of the exponential functions was all of the positive numbers because we could never have a negative number. We had that horizontal asymptote there. So the range was always positive. It was above the x-axis. Therefore, the domain of logarithmic functions is always positive numbers. So you cannot take the log of a negative number. So if you see like log of -7, we would write does not exist or undefined. You can't take the log of a negative number. All right, so throwing a lot at you there. All right, so let's try this last little bit here. So logarithms are used all the time in real life. So they're used for anything that has a scaled value. So think about all the things that have scales to them. Okay, we have the pH scale. Did you guys learn about that in science? We have the, not the fish scales. Nice. We have the decibel scale. Maybe, I don't know, probably. We have the Richter scale, right? All of these things have scales to them.
Tornado scale.
Tornado, is there a tornado scale? I don't know,
Yeah.
maybe.
F5.
Yeah, I guess there is, because they call them like F5, F4, probably. Probably has something to do with logarithms. So anything that has a scale to it uses a logarithm. So this one, so it says a pH scale. So the concentration of hydrogen ions, so we write a hydrogen ion like this, like the little boxy thing over it, so H+, which is given in moles per liter, measures the acidity of a substance. So do you guys remember like the standard, like the neutral substance is water? Do you guys know what water has a pH of?
0, 7.
Of 7. Okay, so anything more than 7 is going to be a base, right? So things like milk is going to be a base. That's why we drink milk or we have Tums when our stomach is all acidy.
And we can say
Anything that's less than 7 is going to be an acid. Okay. So this says the hydrogen ion concentration of moles per liter of a certain solvent is this. Okay, that's our H+. So H+ is going to be 0.00797. So write a logarithmic equation for the pH of the solvent and find the pH of the solvent. Okay, this is a very easy question. We like these on the test. So what we would do is we would say, oh, the pH is equal to the negative log of the H+ of the hydrogen ion concentration. So it's negative log of 0.00797. You can't take the log of a negative number, so I couldn't have a negative on the inside, but I can multiply by a negative on the outside. So this is just putting it into your calculator just like that. So it's going to be negative log 0.00797. And then pH, we usually use 1 decimal for pH. Okay, so we're going to say that this is 2 point, do you guys have it? 2.1. That's the pH.
very acidic.
Yeah, so it's acidic, right? All right, does this section make sense?
Do you know